Hey, welcome back. Today we're going to be watching a video over how to make a lab report. And this right here is the first sheet that I want to show you. This is available to you on Canvas. Um, it's right at the top of the physics section underneath on modules. First of all, I just have this up here at the top. One of the things I want to show to you is the golden rule. You may not use the words I, we, our, mine, theirs, or any pronouns or any person's names in your lab. An example of it being wrong would be if you were to say, our data revealed a trend in percent solid testing. The correct way would say the data reveals a trend in percent solid testing. A lot of times you can get rid of the word, if you say, I can't write it without using a pronoun, try using the word the somehow. That's my best suggestion for you. Pronouns are not acceptable. I take points off. Title, so this should be centered in bold on the page. Well, this is why we have this page. This gives us almost all the information we're going to use. We're going to quite often just take the lab that we used in class and we're going to copy it over here. A lot of times students say, oh, I hate lab reports, it takes so long. I'm like, how? Everything's copy and paste. The next thing you're going to do here is introduction. It says this should be done last. Well, it's going to be, if you to do the introduction, you're writing the introduction for me. And for you to tell me about the lab, you had to have done everything about the whole lab, which includes the lab report. You haven't done the lab report yet. So once you're done with your lab report, except for introduction, then you can write your introduction. Purpose, again, there's some writing there. Basically, you're going to copy and paste. If they don't give you a purpose, you need to, first of all, come ask me, what was the purpose of doing the lab, Mr. Kimmel? And I'll probably give you one. Here you go. I'm copying and pasting it in here. Equipment and materials. Sometimes there are a couple materials that we used that weren't on the list. Make sure you include those. Alright, I'm going to go up here like this. Looks a little bit different, but that's all right. Let's try it again. I didn't like it actually after I said that. I guess it's not going to line up perfectly with the previous ones. Procedure. Do not try to write your own procedure. Why would you spend time trying to write your own procedure? First of all, you're going to mess it up. You're going to mess it up. You're going to try to paraphrase it. You're going to try to really simplify it down. And if it could be simplified any more down, we would have already wrote it that way. Just simply copy and paste it, people. You're going to save yourself a whole lot of time. And you can't write it faster than I just copied and pasted it. Okay, the third section of it. You're going to get in here. Tables. Ask yourself, did my lab have any tables? Well, yes, it did. So I'm going to copy and paste the table here. No, mine's not completely done because it doesn't need to be completely done. But we're getting it all in here. I've got the table. We're going to do some little work with this here in a little bit, see if we can't make that look a little nicer. Typically what we don't want to do is separate a table like this where part of it's on one page, part of it's on another page. There's a few things we can do. For the table. Units in a data table should be in the column heading. Mine are there. I've got them up there. I've actually got them in a couple places. So those are indeed up there. The table must include a sentence or two to summarize the data noting any trends. As we look at this, I've inserted a column here for masses because I know one of the things they asked you to do was mass. So now I've got, oh, what I didn't have up here yet, now it's correct, is I've got my masses in here. So as I notice here, I'm going to make a statement here. As the volume goes up, 1,000 to 1030, it goes from 10 to 13, 1030 to 1100, 13 to 19. Well, what I'm seeing here, and I'm simply going to put it like this, I'm going to say note. The mass volume have a commonality of increasing right along, or increasing accordingly with each other. As one gets larger, so does the other. So there we go. I've got a note in there. Now I'm going to go to graphs. All right. Well, did I have a graph? Well, let's find out. Yes, you're asked to make a scatter plot. So I've clicked where I want the graph to go. I want to start right here. I'm going to go up here to insert. And I'm going to tell it to insert. It says chart, which really means graph. I'm going to go down to Scatterplot, and I'm going to pick, here it is. It's one of the solid lines. So that's what gives me a rough idea. I can hit OK. Now, here's my graph. I need to tell it what data I want to put in here. Well, it said mass versus volume. So, right here. 10, 19, 13. And I just did that wrong. It says mass versus volume. So the first one is the y-axis. The second one is the x-axis. Remember, I know that it goes XY ordered pairs, but when it comes to the names of a graph, when they say it's mass versus volume, the first thing they're giving you is the y-axis. And that's going to be kind of hard for some of you to remember, but I'm sure you'll do all right with it. Remember, up here it says mass versus volume. Mass is the y-axis, volume is the x-axis. By definition, when they tell you the name of something, they're giving you the y-axis first, the x-axis second. I don't care that an ordered pair is an XY ordered pair. I'm not disputing that. I do have it that way. I have volume over here on the x-axis. So I have an XY ordered pair. So I'm not doing anything that's counterintuitive to what you've been taught. Notice here now, here's our graph. What I just found out is that you can't put the data in out of order because it's going from 10 to 19 back to 13. So what I'm going to have to do here is fix the order that it has. And hopefully you guys are seeing that the graph immediately changes right along with that. Some things that I'm seeing right away that I need to fix. Title, mass versus volume. Okay, some other things I want to point out to you. Alright, if you click off the graph, notice that went away up here. That's one way you can make changes on the graph. If I click back on the graph, this comes back up, allows me to make changes, and over here I get these little buttons. Well, this plus button's the one I really care about. This is the one that allows me to add things. Axes titles. Well, this right here is the mass. That was in grams. Axes title. Typically we'll put the units in parentheses. This down here is the volume, and that is in centimeters cubed. That little caret, that little upside down V stands for, tells you that the next thing given is an exponent. I'm going to go up here and hit this again. I got the plus. I'm going to go to trend line. It puts the trend line in there, which is really close to mine, to the line already. And then I'm going to say display the equation on the chart. And for physics purposes, that's all we really care about right now. Alright. Now, note, each graph should have a title. Units on the axis should include that particular axis. A graph must include a sentence or two to summarize the data, noting any trends. So, note, graph shows there is a positive correlation between the mass and volume of the blocks. Calculations. You should include one example of each type of calculation that was computed. Alright, so sometimes they're already in your table. What I like to do with this then is I'll come through here and insert a table. And I think we have like 3 different calculations we did here. So I'm going to show one example of each. I know we did percent error, or percent accuracy, percent error calculation. You guys also were to do a significant, not significant figures. Find the uncertainty, which was the standard deviation. And I think that my table might be a little different than what you guys actually have, because I think this is an older one. And then right here was volume. I don't know, you might have a few other ones that you guys actually had to do. What I typically then will do is I'm going to make 3 rows. One that says what it is, one that shows the equation, and then one where I actually use numbers to show what I got. And in this case, 12, 12.0, and 11.9. So I'm going to plug numbers in. 12.0 times 12.1 times 11.9, and the volume equaled, what was it, 1,000 centimeters cubed. I don't want any of that underline. You do the same thing for the standard deviation, same thing for the percent error. Tell me what it is, show me the equation, put the numbers in, give me the answer. Now we're to the last part here. I want you to realize that I've been trying to show you how to do this and doing it at the same time, and we are currently at only 13 minutes and 28 seconds. So at this point now, it's time for the conclusion. Well, what do I put in the conclusion? Well, the conclusion should be about your purpose. You need to talk about these 1, 2, 3, 4, 5, 6 specific things for this lab in your conclusion. Your conclusion tells me what you learned about these items. Don't write like this. Let me see, the very first purpose. Again, I'm trying to show you what not to do. To measure the dimension of several objects. A lot of students get down here and they say, okay, I got to write about the purpose. The dimensions of blocks. Oh, got to make it sound better. Various wooden blocks were attained. Look at that. Used a lot of great words, and that's not worth any points at all, because this does not tell me what you learned. What this actually is, this would be better to be put up here in the introduction, because the introduction tells us what you, this would be much better to be put here, because the introduction is going to tell us what you did. A lot of times students write a long conclusion. I give them no points because their conclusion is not telling me what they learned. Instead, they took their purposes and wrote an introduction. A lot of students will turn in lab reports that have 2 introductions. Up here they'll tell me what they did, and then down here at the bottom they will again tell me what they did. They don't tell me what they learned, they tell me what they did. So down here in the conclusion, you need to tell me what you learned. A lot of these things should be pointed out in your conclusion, your notes, because those are important things from this, the tables and the graphs. What did you get from the tables and the graphs? And those should go down there in the conclusion. Now that you are all done with the lab, you're ready to write your introduction. Look at your purpose here. Think about your procedure. Think about the table, think about the graph, and write me a paragraph or 2, 4, 5, 6, 7, 8 sentences of an introduction telling me about this lab. It should not be that hard. This should be the easiest thing to do now if you truly did it. Well, hey, I hope this helped you here with the lab report. I'll catch you